Hello and a very warm welcome on behalf of NTI Audio. Today we are talking about the Minirator MR-PRO. This is a very versatile, very powerful signal generator that offers a lot of features and supports a wide range of applications. For that reason, we had to restrict ourselves in this webinar to the signal generation aspects of the Minirator MR-PRO. The other features and functions of the instrument will be presented in a separate webinar in the near future. My name is Markus Becker and I am today assisted by Thomas Hupp, who is taking care of the incoming questions and providing the corresponding answers. The contents that we have prepared for you start with some explanations about the adjustment of a signal level, followed by explanations regarding the Crest factor and the three units dBm, dBu and dBvolt. We will say something about balanced and unbalanced signals and connections before we enter the practical presentation that I have prepared for you. Eventually, we will provide some additional information and wrap up the contents, the key contents of this webinar before we end in the Q&A section. The overall duration of this webinar will be in the range of about half an hour. A signal generator is expected to generate the signal level that you have adjusted. Now, can you always rely on that? Let us take a look on the backgrounds of this procedure. And for that purpose, I have drawn here a schematic sketch of the signal generator MR-PRO with a connected device under test. Well, what the customer does, he adjusts the signal level of the internal generator of the device and expects, of course, that the output voltage, which can be measured at the output pins of the instrument, is the same voltage. However, you have to keep in mind that every existing signal generator always has an internal output impedance. And depending on the amount, the size of the load impedance, the voltage drop across this output impedance can have a noticeable impact on the output voltage, meaning that the generated voltage may be higher than the actually provided output voltage at the output pins. There are three ways to cope with that. The most simple one is what we call the controlled output level. Here, the situation is happening exactly as I said to you. The customer adjusts the generator voltage and expects or hopes or assumes that the output voltage is the same. However, it can be that there is a discrepancy, as just explained before. Most signal generators are operating according to this principle. A little bit more advanced approach is to measure the actual output voltage at the output pins and provide this information back to the user on their own display. We call it the readback display. If you ever have been working with an A2 instrument from the old Neutrik times, you know this readback. That gives you a feedback, a visible feedback on the actual output voltage, and that allows you to possibly fine-tune the generator voltage accordingly until you achieve the requested output voltage. The MR-PRO, however, has an even more sophisticated and comfortable solution. We call it the servo loop output. This is actually a regulated output that basically does the same. It also measures the output voltage and then regulates the generator voltage accordingly so that we have a high high level of identical level between the output voltage, the actual output voltage, and the generator voltage. This is a very powerful feature. You will not find it in very many instruments. It's quite unique for handheld instruments, and it makes the MR-PRO a very powerful device. Just keep in mind that every signal generation has its limits, of course, and the MR-PRO, for that reason, provides a flashing display or starts flashing in its display if the requested voltage cannot be achieved for whatever reason. If the device under test, the load impedance is much too low, if there's a short circuit or whatever, you will see that by a flashing frame on the MR-PRO display. I will show you that in the practical presentation. Well, the next aspect you have to consider when you generate a signal is the shape of this signal. And that is best defined or can be very good quantified or qualified by the Crest factor. What is it? The Crest factor is the ratio between the peak voltage and the RMS voltage. Let us take a look on a typical sine wave. Here we have a sine wave. We have the RMS voltage, which is represented by this dotted blue line. And we have, of course, the peak voltage. Here the top voltage is happening in or achieved by the sine wave. Well, the ratio between these two values is the root of 2. This is a fixed level, a fixed value for sine waves. When we look at the more complex signal, for instance, pink noise, you see here an excerpt of a pink noise signal, we have a higher crest factor. So the ratio of these top peaks in the signal to the RMS voltage is in the range of about 4.5 when we talk about the default pink noise signal as it is provided by the MR-PRO. There are some standards or there are some other solutions that provide, for instance, pink noise signals with lower crest factors, like you see here. The IEC 60268 standard has defined a pink noise signal with a crest factor of 2.0. However, keep in mind that achieving this lower crest factor for pink noise has a major drawback. Because what you do is you cut off these peaks. It's the only way how you can change the crest factor of your noise signal. And by cutting off the peaks, you miss, of course, certain signal components. And when you look at the spectrum, at the frequency response of your pink noise, you will see a major difference between this signal here and the very flat and nice MR-PRO pink noise signal. So it's always a compromise if you amend the crest factor intentionally by cutting off peaks in the signal. Just for comparison, if we look at the music or speech signal, we have typical crest factors of 4 to 10. So that shows you also that this 4.5 crest factor of pink noise in the MR-PRO is a pretty good reference or representation of a real-world signal. What is important about the crest factor is that you have to keep it in mind when you connect your device to the MR-PRO. Because the input range of most audio devices are defined in RMS voltage. And if you have a signal with a very high crest factor, you must make sure that there will be no clipping in your device, in your audio instrument. The MR-PRO will never clip, that is intrinsically safe, that instrument, but you have to keep in mind high crest factors may result in clipping in certain devices that you connect to the MR-PRO. Another topic I want to cover here is the unit. We are frequently asked from customers why we did not implement the DBM unit in the MR-PRO. DBM used to be a very popular, widespread unit in past times, especially good old analog telephony was based or was working a lot with this DBM unit. However, if you look at the detailed definition of DBM, you will realize that it's a rather complex unit that is not very helpful in the audio world. Because DBM is defined as the power level in relation to a reference power of 1 milliwatt into 600 ohm. These 600 ohm are a typical value from analog telephones. So if you have a device under test with a different input impedance, if these 600 ohm change, the whole situation changes, and then you would have to adapt the DBM in the instrument accordingly. This is pretty complex and not really satisfactory. And for that reason, and because the audio world is thinking in voltages, the unit dBu was introduced. Now, dBu is a voltage level in relation to a reference voltage. And here we took the definition was made by taking the 600 ohm impedance, multiplying it by the 1 milliwatt, and that gives us this a little bit awkward number of 0.7746 volt. That is our reference voltage. The good thing about this definition is that dBu and dBm are somehow equivalent. In the ideal setup with the 600 ohm, they are absolutely identical. But if you operate your instrument with dBu, you have almost the same situation as if you would use an old instrument that has the dBm unit. Then there is a third unit, the dB volt. That is a little bit more simpler in definition. It is again a voltage level in relation to a reference voltage of 1 volt. Well, if you want to know the dBm value of a generated level or of a measured level, you can do that by measuring or taking the dB volt value and converting it into dBm by using this formula. So you take the dB volt value, you withdraw this 10 times of the logarithm of the load impedance, the actual load impedance, and you withdraw another figure of 30, and that gives you the dBm result. Now let's start looking in practical aspects of using the MR-PRO. A typical application would be debugging of a stage setup. So you have a microphone connected to a mixing console. Maybe you are encountering some problems of whatever kind. So how can the MR-PRO help you in solving that? First step, you replace the microphone, you unplug it and connect the MR-PRO to it, to the connection, to the cable. Next step would be you verify whether the mixing console, for instance, is generating phantom power. Especially if you have a microphone that requires phantom power, it's of course essential that it is present here at this point, and the MR-PRO shows you this voltage on its display. Next step would be to verify the input stage of the mixing console, and here the balance indicator is a very good help, because if it is not symmetrical, if there is an asymmetry in the display, I'm going to show you that later, such an asymmetry would indicate there is a problem with the input stage. Then you can verify, of course, is there a signal at all arriving at the mixing console. So you generate any signal, be it a sine wave or whatever, and you verify, are these indicators here showing you, yes, the signal is coming in, it is arriving at the mixing console. And another verification you can do is to play around with the level, with the frequency, with the signal form, swapping to noise signals or to others, and listening to the output of the mixing console. Maybe there is an audible distortion that you can hear, and that gives you an indication that there's something wrong in the whole setup or in the mixing console or any involved instrument. Well, I have been talking about this balance indicator, and I want to dig a little bit deeper into this topic. Keep in mind, the MR-PRO always generates a balanced signal, regardless whether you connect a RCA, a cinch cable to the device, or an XLR. Let us take a look on that. Let's start with the XLR. Here you see the sketch, the pinning of the XLR, pin 1 to connect it to ground or to shield, and 2 and 3 are the live and the return signals. So this is the balanced signal. Balanced signals have the big advantage that they are more rugged, they are more robust against external disturbances or interferences. So what is important when you use or connect an XLR cable to the MR-PRO? Do never connect pin 2 or 3 to pin 1, because that would cut off this half wave of the balanced signal, which has tremendous impact, of course. You have no defined situation with the signal generation. You just cannot really operate the device anymore in a reasonable way. Do not do that. If your audio device has only 2 input pins, then just connect pin 2 and 3 and just omit the pin 1 connection. When we talk about the RCA, it's the same situation. Here we only have 2 pins. So we have the live and the return signal connected to these pins. There is no shield involved in the RCA output connection of the MR-PRO. One more hint, a side note actually, because we're talking here about balanced signals, and of course you can also have some problems or issues if the cable, the XLR cable that you connect is not properly connected internally. You can verify that with the cable test that is provided by the MR-PRO. I'm going to show you that to you as well. Now we are here at the point of this practical presentation. I have an MR-PRO here on my desk. I have a special software, the MR-PRO projector software, which is a lab software. It's not available to the public. We use it here internally to display the screen content of an MR-PRO on a PC monitor. You're going to see that in a minute so that you can follow what I'm doing here. And I have a device under test connected to my MR-PRO with an adjustable load impedance. So here you see the screen content of my MR-PRO. You see a typical microphone level, for instance, minus 20 dBu, 1 kilohertz. There is no phantom power present right now. However, we have a nice balanced signal, a nice balanced load impedance, I have to say, to be correct. And here you see the overall load impedance, and I can take a closer look on this load impedance by placing my cursor on this point here, and here you see the load impedance, how it is set up. It is actually 2 times 1.3 kilo ohm. Now I'm going to change it a little bit, and you're going to see what happens. First of all, you see here on the numerical display, it has changed. Pin 3 has now a higher impedance, and you see also the balance indicator has shifted towards pin 3. That shows me there's an asymmetry. So that would be an indication if this would be a mixing console or whatever, an amplifier input, there's something wrong with this input stage because the load impedance should always be identical on both pins. I can also, let's say, reduce the impedance. Let's go here to roughly 600 ohm total impedance. And now let's take a look what happens if I increase the output level of the MR-PRO. It's working fine, it's working fine. So the instrument can still generate this signal level, but at a certain, okay, there's something wrong. Yeah, now I have further reduced, sorry, I had to further reduce my load impedance, and here you see now this flashing frame that indicates you now that this value cannot be actually achieved by the MR-PRO because it is too high compared to this low load impedance. As soon as I reduce the level again to an amount that it can be driven by the device, the flashing frame disappears again. Now let's connect another device to the MR-PRO, and you will see immediately that here, sorry, here we have a device with a phantom power. You see it here automatically. You don't have to do anything about that. It will show you the DC voltage at the input, at the output pins of the MR-PRO. That is an indication there is a phantom power present, and we can also move our cursor on this entry here, and you will see also the distribution, the symmetry of this phantom power of the external device. And a last feature I wanted to show you, I have announced that before, was the cable test. Let me connect now a modified cable to my MR-PRO. Then I have to change the function to cable test. It takes a second, and then it will tell me, aha, this cable has a crossed pin 2 and 3. So the pin 2 of the one side of the XLR has been connected to pin 3 at the other end, and vice versa. So this is a very good indication there's something wrong. I could even play around here with my setup and achieve another or generate another situation with my cable, and then you will see the XLR will immediately tell me what is going wrong. You have always the very detailed feedback on the actual pinning of my cable. Good. Let me get back to my practical presentation and provide some additional information. I guess you know that the MR-PRO can always replay WAV files. There are a couple of WAV files preset, pre-saved on the device, but you can also create your own WAV files and download them to the MR-PRO via the USB link. Just keep in mind that the file format of these WAV files must be 48 kilohertz, sampling rate 16-bit resolution. If your WAV file does not have this format, you have to convert it. But fortunately, NTI offers a free file format converter that you can download from the myntiaudio.com website. And another hint, I have been talking about MR-PRO in this presentation, but I want to give you this hint because it's an important one. If you are a user of the MR2, the small brother of the MR-PRO, keep in mind that this device does not have a servo loop output, but a controlled signal output, the one that I showed to you before at first. So here we have a signal generator with a 200 ohm output impedance. Now, if we would, for instance, connect a 600 ohm load to it, and we would adjust 1 volt output voltage at the generator, then only 0.75 volt will actually arrive at the load, because the difference, the 0.25 volt, will be dropping across this internal output impedance of the MR2. So with the MR-PRO, you are on the safe side. It will always create the correct level, or it will indicate that it's not able to do it. With the MR2, you have to consider the actual situation by considering the load impedance of your connected device. So let me summarize what I have shown to you. This very powerful feature of the low impedance servo loop output, it's actually 12.5 ohm output impedance. We can achieve up to 18 dBu maximum output level with an MR-PRO, which is pretty exceptional for a handheld battery-powered device. We can automatically, the device automatically measures the DC voltage, the phantom power, for instance, that is connected. We have a balance indicator for the load impedance symmetry. We measure the load impedance in detail so that you even get this information. And you are able to download and replay your own WAV files, supposed that they are defined in the correct format. That things that you have to obey, that the output level display will start flashing if the load impedance is too small, for instance. Keep in mind that dBu is the equivalent of dBm. If you are still thinking in dBm, just use dBu and you're on the right side. And keep in mind the crest factor of the test signal that you have selected, and whether your connected audio device might have a problem with high peaks if you have a high crest factor. Well, I'm at the end of my presentation. If you have any further questions or application demands, or there is something popping up in your mind after this webinar, please do not hesitate. We have a very tight network of very skilled partners, sales and support partners around the world. Here we have only listed our subsidiaries. We have also independent partners in all important countries. Just ask them or ask us here in the headquarters if you need any information. So I will say thank you and goodbye for today, and see you soon again.